And what binomial means is that there's two options, yeah? So that bi means two. So either you'll be pass and fail, or be boy and girl, or two specific colors, yes? But there's only two options. So we're just working out the probability when there's only two options. So the probability of exactly k successes in a binomial question is going to be given by your binomial general term, as you can see here, except that k just represents successes, and that p is going to represent your probability of successes, and q will represent your probability of failure. Now, as you can imagine, because it's binomial, so one or the other, that means that the probability of q equals to 1 minus that probability. So for example, if the probability of passing is 0.4, then the probability of failing must be 0.6. Yeah, can you see that? Now, similarly, because it's k successes out of n attempts, so if k equals to your success, that means that n minus k equals to your fails. Yeah? So because it's binomial, it's one or the other. So let's just keep that in mind. So we're just working out binomial probability, and we're just using our general term binomial equation to work it out. So let's have a look at question 1 here. So we find the probability that where p, the probability for pass is 0.2 and the probability for fail is 0.8. And we want to find the probability for the following correcting to 4 DPs. So firstly, when there's 5 passes out of 8. Now, if there's 5 passes, how many fails are there going to be? Good, exactly, 3 fails, because they have to add together to the 8 attempts, right? Now we use that binomial general equation here. So we have 8 attempts, so 8C5, multiplied by the probability of passing to the power of 5, because there's 5 passes, multiplied by the probability of failing to the power of 3, because there's 3 fails there. And then you just need to put that into your calculator and you'll find out the probability is 0.0092. Now, I know a lot of students are going to ask, well, I don't understand. If it's just 5 passes and 3 fails, why can't I just do this times that? Why do I need this 8C5 in front there? Well, this is why. So imagine if you have 5 passes, right? You can have 5 passes, so 1, 2, 3, 4, 5 passes, and then 3 fails here. Or, for example, student 1 and 2 can pass, and these people can pass, and the last person can pass. But these 3 students fail, and so on. So you can have pass, 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 pass here, and then fail, fail, fail there. So what I'm trying to show you is that there's going to be multiple different ways that people can pass and fail. Can you see how there's all these different combinations? Yeah? So because there's all these different combinations, that's why we need to use our combination there of 8C5. So what that 8C5 tells you is how many different combinations of this there are. So instead of us working out the probability of this, which is 0.2 to the power of 5 times 0.8 to the power of 3, and adding each one of these, which can be very tedious, what we're doing is just multiplying that by 8C5 instead, because that tells us how many different combinations there are. Can you see that? So that's why we need that 8C5 there. All right, good. So I hope now that you understand that's why we have that combination at the front of our binomial probabilities, yeah? And not just rote learn it, because it's not very good when you rote learn something. It's always much better to understand it. Okay, so that was for 5 passes out of 8 attempts. Now, what about when you have all fails out of 8 attempts? Now, if it's all fails, that means there'll be 8 fails and 0 passes, right? Now, for this one, it's just going to be 8, because they're 8 attempts, 8C0. and it'll be 0.2 to the power of 0 because there's no passes at all, and 0.8 to the power of 8. Now, I want you to consider this. 8C0 we know just equals to 1. And why is that? Well, because there's only one way that everyone can fail, right? Because if everyone fails, there's not going to be any combinations. So that's why that equals to 1. And just put that into your calculator. So there's 0.1678 probability that everyone fails, which is actually quite high when you think about it in this case. All right, let's move on to question C here. So what if there's at least one pass out of the 10 attempts? So if it's at least one pass, that means there's 1 passes, 2 passes, so on until 10 passes. So that pretty much includes everything except for what? Yeah, exactly, except for when everyone fails, essentially. So we just want to work out 1 minus the probability of 0 pass, yeah? Because this is just the opposite of that. 1 minus this equals to that. Now, we just worked out what 0 pass was, which was in this case will be 10C0 times 0.2 times 0.8 to the power of 10, because there's 10 attempts in this case. Now, 1 minus that, some calculator work. So it's 0.8926 probability that at least 1 passed out of your 10 attempts, yeah? So whenever you see at least with probability, you should be thinking to yourself, I'm probably going to be working with 1 minus something rather than adding all of those together. Okay, now what about D? So here we want to work out more than 4 passes out of 7 attempts. So more than 4 means greater than 4, like that. So that means not including 4. So you can either have 5 passes, 6 passes, or finally 7 passes. And in this case, you're going to have to work out each of these separately and add them together, yeah? So firstly, for 5 passes, you're going to have 7, C5, yeah? So pass to the power of 5, your fail rate to the power of 2. Now for 6 passes, you'll be 7C6 to work out the number of combinations there are. Your pass rate times 6 and your fail rate times 1. And then finally, if it's all passes, you'll just be 7C7, 0.2 power 7, and that'll just be to power 0. Now, I'd recommend you work out each of those separately and then add it all together. It's just, you don't want to have that extra thing for mistakes. So once you've added it all together, this probability is just 0.0048 for that, all right? So you can see it's actually not very difficult what we're doing. All you're considering is these rates to the power of passes and fails, but also multiplying by the number of combinations there are. Now, let's moving on to question 2. So here we meet a very well-prepared student who's going to sit a multiple choice exam with 15 questions, and each of which has 0.1 chance of getting wrong. Now, we want to find the probability that he will exceed 90% in this test. So first thing is we need to work out how many questions he actually needs to get right to exceed this 90%. So to get 90% or better, right, you have 15 questions altogether. So you got to multiply by 90%, and that gives you 13.5. So exceed 90%, that means he has to either get 14 or all of them right, so 15 right. So probably he will exceed that means the probability of 14 correct and then 1 incorrect, plus the probability of 15 correct and 0 incorrect there, like that. So considering this, we're going to have, there's 15 questions altogether, so that's why you have 15C1 there. Now, some people ask, why is it not 15C14, considering it's 14 correct? Well, remember with your combinations, 15C1 is actually exactly the same as 15C14, yeah? Just as 15C2 is going to be the same as 15C13. And because it's binomial, these will always add up to be 15. So it doesn't matter which one you choose. as long as you just stick to one. Yeah, it doesn't actually matter even if you stick to one or not. It doesn't matter which one you choose, they're exactly the same. So just don't be confused by that. So in this case, 15C1, and your probability of passing, getting it correct was 0.1, so power of 1, and 0.9 is to the power of 14. Now here we have 15C0, so this is him getting it all correct. So 0.9 chance he's going to get it correct, power of 15, and there's nothing that he gets wrong, so power of 0. Let's work them out separately, add them together, and we work out that this very well prepared student actually has a 0.5491 probability of getting more than 90% in this exam. All right? Okay, so just remember for these questions, all you need to do is think it's binomial. You need to work out what these probabilities are going to be first of all. So 0.9, 0.1, how many attempts there are, so that'll be 15. And it doesn't matter if you put 1 or 14 there, it's going to give you the same answer at the end.